Hey guys, welcome back to the channel. So here in this live we are going to see. So the first the first question is, what is the difference between .NET framework and .NET Core? So the .NET framework is an old legacy framework, and it is in a Windows only platform which is designed to run only on Windows. It does not support cross-platform development, and dependency injection is not built in the .NET framework. So, and the .NET framework is mostly used for building traditional desktop applications like Windows applications, and slower the performance than .NET Core. So here .NET Core is in a modern, lightweight, open source. It supports a cross-platform. It supports the cross-platform development. So we can run the same code on Windows, Linux, and Mac, which is great for microservices and containerization with the Docker. So .NET Core has built-in support for dependency injection. In terms of performance, .NET Core is faster, especially for Web API and microservices. So .NET framework is an older and legacy framework. It is only used with the Windows only platform, which designed to run only on Windows. It does not support the cross-platform development. So .NET framework does not support the cross-platform development. So and in a .NET framework, dependency injection is not built in, and in a .NET framework, dependency injection is not built in. So, and it is slower performance than .NET Core. And the .NET framework is mostly suitable for the older applications, that is, a desktop applications and Windows Forms and WPF and enterprise level web applications. So, this is the new version of the .NET Core, and this is a new .NET Core version. Yeah. So, what is the difference between .NET Framework and .NET Core? So, you can see here, .NET Framework is in a legacy platform, mainly for Windows-based enterprise applications. It is not an open source, and we mostly use it for apps that rely on a technologies like a WPF and Windows Forms and ASP.NET Web Forms and WCF. .NET Core, on the other hand, is in a modern, lightweight, open source. It supports the cross-platform development, so we can run the same code on a Windows, same code on the Windows and Linux and Mac OS, which is greater for microservices and containerization with the Docker. In terms of performance, .NET Core is fast, especially for web APIs and microservices. It also allows side by side versioning, so different apps can use different runtime versions on the same server. Advantage over the framework. A main major improvement in .NET built-in dependency injection. Built-in dependency injection .NET framework, we had to bring external libraries like Artifact and or Unity. But in a .NET Core, dependency injection is built in and integrated seamlessly with the middleware and services. It is .NET Core is better supported for microservice architectures, and with the native support for gRPC and minimal APIs with better Docker compatibility. So to sum up, for for new development, I will go with the .NET Core, .NET 6, .NET 7, .NET 8. It's modern and performant, cloud ready, and supports the kind of modularity and testable architectures we need. So the .NET framework still has its place for legacy enterprise applications, but it's no longer actively involved with the .NET 5. And so it key advantages of using the .NET Core. It's a cross-platform, performance is big plus, is built in, side by side versioning, and .NET Core is open source and has strong community behind it. It's cloud ready and supports microservices architecture, and .NET Core has modern development experience, and with the powerful CLI tools, fast builds, and better memory usage, and great integration with the Visual Studio Code and CI/CD pipelines. What is the role of startup.cs file? So, what is the role of startup.cs file? So, startup.cs file have the startup constructor will set the configuration related things with the iConfiguration service interface. So startup constructor will set the configuration related things with the iConfiguration interface. So before 6, we have the configuration services and configure method. So after 6, it is unified as a single file. It is in a program.cs file. So here, configuration services method configures the services which are required by the application. So configuration services method configures the services which are required by the application. Configuration services method configures the services which are required by the application. Configuration services method configures the services which are required by application. So configure method is responsible for build the HTTP request pipeline as a series of middleware components. Configure method responsible for building the HTTP request pipeline as a series of middleware components. So configure method is responsible for build the HTTP request pipeline as a series of middleware components. So here you can see from the .NET 6 place, the startup.cs file class have been removed, and con- its content is merged in the program.cs file. So you can still use the startup.cs file in a .NET 6 plus by calling web builder dot use startup and startup, just like in a .NET 5. So you can, what is the difference between and launch setting.json? So app setting.json stores the runtime configuration values. App setting.json stores the runtime configuration values. App setting.json configuration values which are required when an application is so stores the runtime configuration values which are required when running. App setting.json file stores the runtime configuration values which are required when an stores the runtime configuration values which application is running, such as database connection strings and logging settings and custom keys and values and API URLs and flags and keys and SMTP settings. And so app setting.json stores the runtime configuration which are required when an application is running, such as database connection strings and settings and custom keys and values and JWT keys and AP settings. So app setting.json stores the runtime configuration values which are required when an application is running, database connection strings and logging settings and custom keys and values and API URLs and JWT keys and SMTP settings, etc. So launch setting.json stores the configuration values which are required to start an application. Launch setting.json stores the configuration values which are required to start an application. Launch setting.json stores the configuration values which are required to start an application. The key things is like which port the app should run, the which port the app runs on, and whether the launch a browser, the environment is development or staging and production. So multiple profilers can be created, so IIS, Express and Crest. So configure the values which are required to start an application. So launch.settings is JSON is stores the configuration values which are required to start an application. Stating.json stores the runtime configuration values which are required when an application is running. So launch.json stores the configuration values which are required to start an application browser like that. What is the dependency injection? What is the dependency injection? Dependency injection is a software design pattern which is used to of control. Dependency injection is a software design pattern used to achieve the inversion of control between the classes and their dependencies. Dependency injection is a software design pattern which is used to achieve the inversion of control between the classes and their dependencies. Instead of a class creating its own dependencies, they are injected from the outside. So dependency injection is in a software design pattern which is used to achieve the inversion of control between classes and their dependencies. Instead of a class creating its own dependencies, they are injected from outside. Instead of a class creating its own dependencies, they are injected from the outside of the class. Dependency injection promotes loose coupling and testability and maintainability. Dependency injection promotes loose coupling, testability, and maintainability. Dependency injection helps us to Dependency injection helps us to avoid tight coupling instead of creating an objects directly with the new keyword. Dependency injection helps us to avoid tight coupling. Dependency injection helps to avoid tight coupling. Dependency injection helps to avoid tight coupling. uh, Dependency injection helps to avoid tight coupling. Instead of a object creating so instead of creating a objects directly with the new keyword instead of creating a objects directly with the new keyword, we can inject them via interfaces into the constructors and register them in the DI container. Dependency injection helps to avoid tight coupling, and instead of a class creating an objects using the new keyword, we can use the interfaces that injected into the constructor and register them in a DI container. So dependency injection helps to avoid tight coupling. Instead of creating objects directly with the new keyword, we can use the interfaces, can inject them We inject them via interfaces into the constructor and register them in a DI container. For example, I have an appointment implements in a I appointment repository interface. So, for example, I have an appointment repository that repository interface. It handles the things like scheduling, canceling the appointment. For example, I have an appointment implements I appointment repository interface, and it handles scheduling, rescheduling, and canceling the appointment. I have an appointment repository that implements I appointment repository interface the things like scheduling, rescheduling, and canceling the appointment. For example, I have an appointment repository that appointment repository interface. It has like scheduling, rescheduling, and canceling the appointments. So if tomorrow I wanted to do some testing on that repository, that endpoint. So I will replace my appointment repository that returns in-memory test data real database. So if tomorrow I want to do testing, I will replace my appointment repository with a mock repository that returns in-memory test data instead of hitting the real database. So I can easily do the testing, unit testing without touching the controller logic and by changing the DI container. Let's assume later we had a requirement to log auditing data also. So if tomorrow I want to do test my appointment repository with a mock appointment repository that returns in-memory test data instead of hitting the real database. Easily do the test unit testing without touching the controller logic by changing the registration on in a DI container. So let's assume later we had a requirement to log auditing the data also. Let's assume later we had an requirement to audit the data also. Instead of going back and modifying the existing appointment repository or changing the controller logic, instead of going back and modifying the existing changing the controller logic, simply create a new audit appointment repository. Simply create a new audit appointment repository. Simply create a new audit appointment repository that implements the same interface I appointment repository. And instead of going back and modifying the existing appointment repository or changing the controller logic, simply create a new audit appointment repository that implements the same interface I appointment repository. And inside audit appointment repository and inside audit appointment repository class, inject the original appointment repository, inject uh, repository also, add auditing logic before and after the actual repository calls, then with audit appointment repository instead of going back and modifying the existing appointment repository or changing the controller logic, simply create a new audit implement the same interface I appointment and inside inside audit appointment repository class, inject the original appointment repository and auditing the logic before and after the actual repository calls. Then just update the DA container registration with audit appointment repository instead of repository. Instead of going back and modifying existing appointment repository or changing the controller logic, simply create a new audit appointment repository that implements the same interface appointment repository. And inside audit appointment repository class, inject the original appointment repository also, and add auditing logic before and after the actual repository calls. Then just update the DA container registration with audit appointment repository instead of appointment repository. So third, ERP and ERP services usually have other nested dependencies without a DA. So writing long chain of new statements and manual, which gets messy and harder to maintain. DA handles all that behind the scenes. Dependency injection gives us lifecycle control, like deciding whether the service should be at singleton, scoped, or this is a super useful optimization resources. For example, using a single DB context per request. So also dependency injection gives lifecycle control, like deciding whether a service should be singleton or scoped or transient. This is a super useful for optimizing resources. For example, using single DB context per request. Another big reason is that the ASP.NET Core is built in with dependency injection in mind. All built-in services are like logging, configuration, and database context rely on it. So if we didn't use dependency injection, we miss out on lot of what the framework offers. And finally, dependency injection, and if multiple controllers need the same service, we don't create it in each one. Once it's registered, we just inject it whenever needed. So overall, dependency injection helps us to build clean and testable and scalable applications, which is especially important in a complex healthcare system where readability and flexibility are critical. In a .NET Core, dependency injection in a .NET Core dependency built in and configured in the program.cs file and file. Using the iService collection, services are registered with the lifetimes like transient, scoped, and singleton. In .NET Core, dependency injection is built in and configured in a program.cs file or startup.cs file. Using the iService collection, services are registered with the lifetimes like in a transient, scoped, and singleton. A new instance is created every time. 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 Transient is a new instance is created every time. Transient means Transients means a new instance is created every time the service is requested and disposed immediately after the use. A transient means a new instance is created every time A transient mean a new instance is created every time. New instance is created every time the service is requested and disposed disposed immediately after the use. Scoped a single instance per HTTP request. So here a new instance is created for every time the service is requested, and in a scoped a single instance per request, HTTP request. So scoped means one instance is created per HTTP request. Scoped means one instance is created per HTTP request. One instance is created per HTTP request. That same instance is reused throughout the request. Scoped means one instance is created per HTTP request and that same instance is reused throughout the request. Scoped means one instance is created per HTTP request and that same instance is reused throughout the request, so it's shared across the controllers, services, and repositories involved in that request. So scoped means one instance is created per HTTP request, that same instance is reused throughout the request, and so it's shared across the controllers and services and repositories involved in that request. A single instance is created throughout the application lifetime. A single instance is throughout the application lifetime. A single instance throughout the application lifetime. A singleton means a single instance is created and reused lifetime of the application. A singleton means a single is created and used throughout the entire lifetime of the application. Every part of your application that needs this object. A single instance throughout the application. Singletons means a single instance is created and reused throughout the entire lifetime of the application. Every part of this service gets the same shares get disposed by lifetime. So at transient services are disposed immediately after the use. Assume the DI them, but if you create and manage them manually, then you are the responsible for disposing them. At transient services are disposed immediately after the use, and scoped services are disposed at the end of the HTTP request. Services are disposed at the end of the HTTP request. So if a service like a DB context is a scoped, it's automatically disposed once the request finishes its processing. Services are disposed at the end of the HTTP request. So if service like DB context is scoped, it's automatically disposed once the request finishes the process. Singletons leave for the entire application lifetime. It's leave for the entire application's lifetime. They are disposed they are disposed only when the application shut down during the apple recycle and application stop. So live for the entire application lifetime, and they are disposed only when the application shut down. What is the middleware? middleware is in a software component. Middleware is in a component that assembled into an application pipeline to handle request and responses. Component that assembled into an application pipeline to handle in ASP.NET Core. Middleware can be implemented in a three ways. In .NET Core, middleware can be implemented in a three ways. The most common approach is to create custom middleware class. The most common approach is to create a custom middleware class in a software component that assembled in an application pipeline to handle the request and responses. And in ASP.NET in a three ways. The most middleware class with the constructor class with the constructor that accept the request delegate and implement the logic in the invoke async method. All can use iMiddleware interface, which enables the ASP.NET Core's dependency injection system to inject certain middleware. After defining the middleware application pipeline using the use middleware type T. So, last middleware can be used with the lambda expression directly in the programs.cs file or startup.cs file, which is which is ideal for operations like logging and setting the custom. Middleware is particularly useful for handling and cross-cutting concerns such as logging and exception handling and adding the custom headers. So middleware is in a software component that application pipeline to handle request and responses in ASP can be implemented in a three ways. The most common approach is to create a custom middleware class, a class with a constructor that accept the request delegate and there is a software component that's assembled into an application pipeline to handle request and responses. And in a ASP.NET Core, middleware can be implemented in a to create a custom middleware. Create a class with a constructor that accept a request delegate and implement the logic in the async invoke async method. High middleware, which enables the ASP.NET Core's built-in dependency injection middleware. After defining the middleware, the application pipeline using the use middleware type T. Lastly, for simpler tasks, use inliner middleware can lambda expression directly in a program.cs file or startup. Which is ideal ideal for opening for operations like logging and setting custom headers and custom middleware is a particular useful for handling the cross-cutting concerns such as logging exception handling and adding the custom headers. What is middleware order is also important in a .NET Core. Middleware order matters a lot because each middleware decides whether to pass the request forward to or short circuit it. So in .NET Core, middleware order matters a lot. In a .NET Core, middleware order matters a lot because each middleware decides whether to pass the request forward or short circuit it. The order of middleware in a request pipeline is critical. The order of the order of middleware in a request pipeline is critical because each middleware can short circuit the pipeline, means stop the further execution, and it depends on the outcomes of the previous middleware, or modify the request and response before passing it. So along with use exception handler, and use HTTP redirections, and use static files, and use routing and authorization and authentication and authorization and controller endpoint at the end. Okay. What is the routing in ASP.NET Core? Routing routing is the routing is the process of mapping the incoming HTTP request to the corresponding controllers or action endpoint. So, what is the routing? Routing in ASP.NET Core. Routing is the process of mapping incoming HTTP request. Routing in ASP.NET Core. Routing income mapping the incoming HTTP request to the appropriate. So there are two main types of routing. There are routing. First one is conventional routing and attribute routing. Conventional routing and attribute routing. Conventional routing and attribute routing. So conventional routing defined in a program.cs file or startup.cs file using the map controller route. Conventional routing defined centrally inside the program.cs file or startup.cs file in the map controller route. Conventional routing defines a central program.cs file or startup.cs file using the map controller route. A route template like a controller, action, and ID uses the route template like controller, action, ID uses route template like controller, action, and ID. Example: and product list map to the list action and in product controller. Okay. Best suited for the standard CRUD MVC apps. It is best suited for the MVC applications. So attribute routing defines directly actions using the route and HTTP GET and HTTP POST. So conventional routing program.cs file or startup.cs file using uses say route template like a controller, action, and ID. Example: products list, and maps the list uh, products controller. For standard CRUD MVC apps, uh, defined directly on a controllers or actions using the route and HTTP GET, HTTP POST, and etc. So gives more flexibility, especially for web APIs. And example: square brackets and route API slash patient slash ID supports the route constraints and optional parameters and by we define the routes using the attribute. We define the routes using the attribute routing or directly control actions using the route and HTTP GET, etc. and or conventional routing in a program.cs file using the map controller Attribute routing gives us more. For example, route API patient slash ID maps to the specific patient ID. Route also supports route constraints and optional parameters and default values. Routing maps incoming URL to the controller actions. There are two main types. So that the difference between attribute routing and conventional routing is that attribute routing is applied on directly on controller and actions, given more flexibility, and conventional routing is defined in a program.cs file or startup.cs. So the difference between routing is applied directly on the on controller actions, and conventional routing is defined in program.cs file using the route parameters, route patterns. What are the filters in a ASP.NET Core? What are the filters in a ASP.NET Core? Filters in a .NET Core allows to run code before and after the specific stages in the request processing pipeline. So filters are allows to run code before and request processing pipeline. There are mainly exception and authorization and formatting responsibilities. So there are different types of filters, each running at a specific point in the requests. So first one is an authorization filter and a resource filter and action filter and exception results filter. Author resource filters and check resource filters and action filters and exception filters and results. I'm ending this live now. 30, 40, 43 minutes.